Hey, training plants every day. Jordan Scovel coming at you from the Hadron Collider, the Bluestone Collider, the particle accelerator here. And, in the past I've talked about systems that have zero mass and zero force. Okay, so in the STEM game, you're dealing with a lot of tutorials. How to thermal, how to use a forklift, how to cut bluestone, how to deal with crew, how to power wash or anything along those ideas. In those frames of reference, everything has zero mass, everything has zero force. We know that's the observable universe, but in terms of what direction, what timeline, what spaces you're going to be dealing with, it's like saying, I don't know the momentum, I don't know the position, I just know general relativity. I know that those are the base raw numbers, and in that special relativity, that's going to dictate what that is. X, Y, and Z. A combustion engine, pressure washer, obviously you have a volume reduction problem, which is probably somewhere, if you look hard enough, in general relativity and special relativity, under some term or the other. However, in daily operations, a lot of the things I do, I occupy the standard idea that they have zero mass and zero force. So what am I saying? I'm saying, well, look at these right here. Those are 1 by 3 2-inch pieces. So 18 pounds a square foot for an inch and a half, something like it's 1880 or something like that for 2-inch. That starts to ramp up pretty fast when you get into 4-footers and 5-footers. You've been carrying this stuff around all day by hand. So that's essentially its weight. But out here in the STEM land, this has more to do with that its atomic weight in the STEM particle that it is zero. The internal mass of this situation is zero. It sits here, it has reverse time symmetry principles, it has wave functions and how it's occupying this field, how things in the field occupy against this and will affect it, therefore change its mass and timelines and spaces and what have you. But for me, as a guy that has to work a lot of this, kind of knowing or believing at least that this system has a zero mass weight, it certainly makes big differences with how fast you are and how strong you are. Now, don't get me wrong, there's some physical weight behind this stuff that you're going to have to adapt to. You're going to have to learn how to get the hell kicked out of you by that torch. It's going to burn you. It's going to happen. But knowing those ideas that each of those things has a zero mass system, does the burn really affect you? Yeah. But mind over matter keeps me going. It's not going to weigh so much on me because I understand that that's a zero mass system. It ain't going to change. That's the number. It's going to happen. The weight of those rocks aren't going to change. But what we're talking about here really isn't physical weight. But by knowing sequences, by knowing series of events that in their entirety of the state or the field, that they are a particle, that they are an effect, that they are an element on their own, it begins to reduce the weight of that object. Why it affects certain timelines in the shop. You're starting to understand the physics in this universe a little bit better, and therefore your moves are going to be more precise. They're going to be more calculated in terms of your timelines, your spaces, the choices you make while looking at things. There's a stack of rock here, I'll be burning it. As I'm working it, I'm going to be looking at things. Certain jack in it, is it worth the time to flip it? Do I got to save this off for pattern, or am I going to use treads for it later on? I'm going to split that out amongst this space. Maybe that's all jammed up so it would change my operation. That particle, its mass changes, and we use the physics of that. Just like reading this to say whether, well, there's obviously an 18 or a 2, but looking down into the rest of the stack, I'll begin to pick 2 or 3 of them off. I'll run 2 on the ground, and I'll go, well, this is all pattern rock. This whole particle has a mass of pattern, and that's what I'm going to use it for. Treads, I can't do it. If it was good like that, I'd say, hey, let's use it all for treads. That makes the weight of the situation. While you're standing there, oh, damn, what do I got to do? Oh, fuck, and you're just standing under a mountain trying to hold it. Gravity is pounding down on you all day, every day. Or you could look at it from the other side of the quantum spectrum. You could say to these ideas, hey, I do understand the physics in this observable universe. The horizons that I can see beyond this point in time right now are calculable. And those horizons change. The frame of reference you might deal with changes pretty damn rapidly. So you have to be aware of it. But again, like I said in my video yesterday, we start to close it off a little bit here. And then you're going to learn a new calculation. You're going to get used to that physical term or that physical number or that physical idea adapting into this system, and you're going to climatize to it. You, the particle here, you're affected by that, so you're going to move like a photon around a black hole. You're going to move like a planet around a sun. That becomes gravity. That should be exactly where it is and how it's going. Now, obviously, the calculations that physicists deal with today, there's still lots of questions, there's still lots of holes in this function. You're going to have those in your day operation. You're going to have little things that you're not really expecting that thing to come out of nowhere. It's back here. Your horizon's in front of you, and you're trying to pay attention to that. But your horizon, when you climatize, is going to get much better. You're standing in the middle of this thing, bouncing around, bing, 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 bing. So you should know, by the sound of that saw, by the sound of the people in the room around you, how they're talking, what's going on, more of the information that's going to make you a little bit more apt, that's going to make you a little bit stronger, it's going to make you a little bit faster. And again, what we're talking about here isn't necessarily physical strength. And I'm 5'9", 150 pounds, but I throw this stuff around all day. You know, I make choices. Is it worth me to pull it off the table by hand? Is it not worth me to pull the stuff off the table by hand? What else is going on in the room? If I didn't do that by hand here, is it going to cost me more time, more energy later? So even if I did it like that, pulled it off by hand, that doesn't necessarily make it the fastest, smoothest move. But across the board, at the end of the day, you're banging stuff out. And that's going to make you look way stronger. It's going to make you feel real strong. It's going to make you feel more accomplished and like you've achieved something. So I'm going to drop that note into you today. This is the force. This is the grind at zero mass. This is the grind at zero force. And we can get out here and look at some of this stuff. And it's not in operation right now. We're on lunch break. But even if we weren't, every day around you, you have the opportunity to break down the tutorials, the steps of your day, blueprint it, map it, in this field right here. You know, somebody decided, hey, I'm going to know the physics of a thing. No, hydraulics does this. Then I'm going to put some wheels on it, put a seatbelt on it, and twirly whiz bang, now you have this new blueprint, essentially. This new particle, this new element that's created into this field. I'll tell you, that's a handy little mother trucker right there. But anyways, that's my note for today. I'll catch you on the next one.